I'm Jeremy Sager. I'm a research engineer at CanmetENERGY Ottawa in Bells Corners. And my role is to assess the performance of different more energy efficient heating, ventilation, and air conditioning systems. Today we are checking data together with Alexandre, a co-op student. We're checking the data from the system, making sure everything's working as expected. Alex is checking, for example, right now he can log into these sensors and then he can see the data from the sensor on his phone.
So the loggers collect data every 5 minutes, and the last time I came to collect data was 3 weeks ago. So do the math, 5 minutes for 3 weeks, that's a lot of data, so it takes a couple minutes for my phone to collect everything. Then it generates a mini graph, which we can see right here. And then I export that to Excel, and I send that to the office, and we can analyze that at the office.
We've done research on air source heat pumps for several years now. And so we started thinking, well, what about the possibility of replacing an air conditioner with a heat pump? So when your air conditioner gets old, then the heat pump could do some of the heating and save energy. So that's what we did in this house. And then we started to look at the energy consumption and comfort impact. So this is one type of air source heat pump for a hybrid system outdoor unit. It's side discharge, so it draws air in from the side, blows air out the front. So if it's snowing or there's freezing rain, that's going to land on top of the unit and not impact the airflow of the unit. Once it gets above -8 outside, and if it's off-peak, then it's going to switch to the heat pump. There's also a phone app for this, and the phone app tells you what the system has been doing over the last 24 hours, what it's going to do over the next 24 hours, how much energy savings there were, and whether there was greenhouse gas reductions. This is the system on February 8th, and we can see that the greenhouse gas emissions reductions were 30% for that day. And there was 7.58 kilograms of CO2 reduced. And it ran the heat pump from 12 a.m. to 6 a.m. We're expecting greenhouse gas emissions reductions of 20% or better. And that really depends on location and what you set your thermostat to. But that's ballpark what we expect from this approach.
If you like this video, let us know with a thumbs up. Click on the logo below to subscribe to the Simply Science channel and click the bell icon to be notified when we upload new videos.